Page 192, number 13. Y equals 2x minus tangent of x between negative pi over 2 and pi over 2. Determine the open intervals where the graph is concave up and concave down. So concavity intervals, that means use the second derivative. Just looking ahead, derivative of tangent I know. Derivative of that's going to be a pain maybe. So y prime is 2. Derivative of tangent is secant tangent. Okay, not bad yet. But I need to do a second derivative. Derivative of 2 is 0, so hey, that's nice. Wipe that one out. But for the second piece, I'm going to leave the minus sign out front. And I'm going to have to do a product rule. If f is secant, derivative of secant is, wait a minute, I did that wrong, right? What's the derivative of tangent? Secant squared. I was jumping ahead here. Derivative of tangent is secant squared. You got to stop me before I get too far along in my mistakes. The derivative of secant is secant tangent, and I'll need that here. So the derivative of secant squared, remember the derivative of anything squared is 2 times the thing times the derivative of the thing. So 2 times the thing times the derivative of the thing. And the derivative of the secant is secant tangent. So that's kind of weird. The secant x, or the 2 secant x, is the derivative of secant squared. And then the chain rule gives us the secant tangent part. Are we okay with that? Especially after I messed it up to begin with? So the second derivative is negative 2. Well, secant squared shows back up here. Secant squared x, tangent x. And concavity intervals. So we want to know where this thing is 0. Or undefined. You know what might be easier? Is if we, instead of having secant, what's secant partnered with? Who is his reciprocal buddy? Cosine. So let's rewrite this as tangent of x over cosine of x. Because I'm thinking ahead, I'm going to need zeros at the top and zeros at the bottom. So it's okay that I have a denominator. In fact, you know what? Tangent is sine over cosine. So why not just put it all in terms of sine and cosine? We know that better anyway. Uh-oh, I messed something up. Cosine squared. Yep. So negative 2 sine of x over cosine cubed of x. I don't have to work it this way, but I didn't really want to mess with tangent, and I really didn't want to mess with secant. So you can avoid that if you switch stuff to sines and cosines. Especially since we're headed towards setting the top equal to 0 and the bottom equal to 0. So it's still a big deal to have a denominator. So sine of x is 0 when x is 0 and pi and 2 pi, although I'm only allowed to look between negative pi over 2 and pi over 2. So pi's out and 2 pi's out. And then it's undefined when cosine is equal to 0. Right? Like some of you have mentioned this already, the parallel thing going on with the second derivative stuff and the first derivative stuff. Like we do the same thing. We find where it's 0, where it's undefined, we put them on a number line. It's just our conclusion is different. Here we're going to be concluding things about concavity. Let's see, cosine is 0 when x is pi over 2 or negative pi over 2. But those are the endpoints of the interval anyway. And in fact, this had a parentheses there, so we weren't even allowed to include those. So those are out. So we started with this big field of possible, not critical points, but important points for the second derivative, and really there's only one. X equals 0. So we need to check the second derivative because we want to know about concavity intervals. I guess the trick is I need something less than 0, but I'm limited. It said don't go past negative pi over 2 or go past pi over 2. So I guess I'm going to have to check negative pi over 4 and pi over 4. I guess if you're more familiar with pi over 3 or pi over 6, you could check those too. So I'm looking back at the second derivative. See if I can fit all of this on the screen at once. So negative 2 sine of negative pi over 4 over cosine cubed of pi over 4. Well, the good news is all I care about is positives and negatives. So negative 2 sine of negative pi over 4 would be negative. The cosine of negative pi over 4 is positive. So negative 2 times a negative number divided by a positive cubed number. All that to say we're negative. Which means f is concave down on negative pi over 2 to 0. If I'm pressed for time, I would guess that the other one's concave up. But let's check to make sure. Especially with trig functions, you never know. Whoops, positive pi over 4. Cosine pi over 4. Wait a minute, I made a mistake. You guys are not on your game today. I'm not either, but I'm going to blame you. Over here, I've got negative 2 times a negative number. That should be positive, which makes this should be concave up. All right, back to this one. So negative 2, everything's positive over here. Negative 2 times a positive over a positive cubed. It's negative. That's what the second derivative is. So the first derivative then is concave down from 0 to pi over 2. Also means there's an inflection point there at 0, but that particular question didn't ask for a inflection point, but while we're there, point of inflection at x equals 0. I'm not going to graph this one because that would take too long to type all that in.